G'day everyone, so in this video here we're going to be looking at solving algebraic equations, specifically looking at algebraic fractions, okay? So our algebraic fractions that you will see, these are these here, okay? This is all an algebraic fraction here, okay? So they are algebraic fractions. So that's what we're going to be looking at today, alright? And we'll just get straight into it. Just remember, you need to do the inverse operations to get to isolate or get our letter by itself, okay? And we'll go through how to do a few different ones. So 5k over 2 is equal to 20. So just remember, we need to look at essentially what's furthest away from our unknown. What's the easiest thing to get rid of, okay? Hopefully you realize this is this 2 here, okay? Because all of this is being divided by 2. So what we need to do is, what's the opposite of divide by 2? That's times by 2. Times by 2. So this leaves 5k on this side. 20 times 2 is 40. Alright. Now we've got 5 times k. So opposite of multiply is divide. So we divide both sides by 5. Okay, so k is equal to 40 divided by 5, which is equal to 8. Alright, so that's how we do the first one there. Going to do b up the top here. So b, we have 3y plus 6 over 2 is equal to 9. So this one's very similar like our first one, okay? We need to look at what's furthest away from our y value. So essentially you need to think of it like we've got brackets on here. So this actually can be written as 3y plus 6. All of this is being divided by 2, okay? So what's actually easiest to get rid of is our divide by 2. So we need to multiply both sides by 2. Okay, you don't need to write it out like this, I was just doing this to show you. So just make sure that you are multiplying it by 2, okay, and not, so make sure you're not minusing 6 first. That's a very common mistake for this one, okay. So we're left with 3y plus 6 is equal to 9 times 2, which is 18, okay. Now, our 6 is the furthest away, our plus 6, so we need a minus 6 from both sides. And it's really good just to show you steps, especially when you're starting to do this, just so it's easy to find a mistake if you do one. Okay, it's very easy to make silly little mistakes. So then we've got 3 times y, get rid of it, 3 times y we need to divide by 3. Okay. So y is equal to 4. Alright, so that's how we go about this one. So C. Just doing this so it's easy to see where they're all separate. So C, we have 2 plus 5x over 3 is equal to 12. So make sure you're looking at essentially what's furthest away from our x, what's the easiest thing to get rid of. Hopefully you realise it's this plus 2 hanging by itself at the end. Okay, so this positive 2. So to get rid of positive 2, we need to minus 2. So we're left with 5x over 3 is equal to 10. Now, we've got 5x divided by 3, so the easiest thing to get rid of, hopefully you're realising this well, is our divide by 3, so we need to multiply both sides by 3. So 5x is equal to 30. Now we have 5 times x, okay, so we need to divide by 5. So just remember all your inverse operations. Okay, have them handy if you get a little bit confused. So x is equal to 30 divided by 5 is 6. Alright. So lastly we have ten minus 2x over 3 is equal to 4. Alright, so with this one we look what's sort of furthest away from our x, what's easiest to get rid of? This positive 10 out the front. To get rid of a positive 10 we need to minus 10 to both sides. So this leaves us negative 2x over 3. Don't forget that negative out the front. That's a very easy mistake to make. 4 minus 10 is negative 6. Sometimes when we do have a negative out the front, I like to get rid of it. You don't have to, so I'm just going to show you how you can actually get rid of it, and then I'll erase it. So if you've got a negative out the front, if you ever have a negative, or you want to change the sign of anything, you can just multiply both sides by something like a negative 1. Okay, or divide by negative 1, doesn't really matter. Okay, and then you would be left with 2x over 3 is equal to 6. Alright, so you can always do that. And then you can continue working it out as per normal here. Okay, so you would multiply both sides by 3 and then divide by 2. Okay, so there would be x equal 9. So I'm just going to show you that you can do this, and I'm going to show you a different way of doing it. Just remember x is equal to 9 if we don't do it that way, just to prove that you can do it both ways and it doesn't matter. So here on the bottom here we've got, this is all being divided by 3. Okay, so to get rid of it, opposite of divide by 3 is multiply by 3. So we're left with negative 2x. Multiply by 3 is negative 18. And now we have essentially negative 2 times x is equal to negative 18. So we need to, hopefully you realize, divide by negative 2. That's a horrible 2 there. So now we're left with x is equal to negative 18 divided by negative 2, negative 2. So 18 divided by 2 is 9. The negative divided by a negative makes a positive, so this is going to be positive 9. And that's just like the answer we got before. Okay? So just with this, just make sure that you are doing the right steps first, so isolating your unknown. Okay? So make sure you're isolating your unknown. Remember, unknowns can be any letter, and just do your inverse operations. And so with this, our first example here, we had to multiply 2 first, then divide by 5. Okay, our second example, we had to multiply by 2 first because all of this at the top was being divided by 2. Okay, so that's why we multiplied 2 first. Then we continued on with the rest of them. Our first example, we had to get rid of, our third example, we had to get rid of this positive 2 out the front, okay? And then it left positive 5x over 3. All of that's being divided by 3, so we need to multiply by 3. Alright, and our last example is pretty similar. First, get rid of the positive 10 out the front by minusing 10, and then multiplying 3 because all of this on the top is being divided by 3. Okay, so all of that is being divided by 3, so you need to multiply by 3, and then we can divide by 2. So hopefully this helps with solving algebraic equations, specifically looking at algebraic fractions. Alright, so good luck.